You're welcome in maths, and I got a new video on this video series. So in the previous video we have discussed this, so now let's move to the part 8. So today we will going to discuss about the golden angle. So for that, let's draw a circle, and this is the center of the circle. This is whole 360 degree, and now you draw the two lines, means making two sectors, and these are, let's say, A and B. And you know, Euclid has given the extreme and mean ratio, as you know, and this ratio has how converted into the golden ratio I have told you. Now the extreme and mean ratio is basically what I have told you in my first lecture of this video series, that A plus B by A is equals to A by B, okay, in which A is greater than B. Now you can see that A by B, this ratio will be what? 5. So this is also totally 5, and 5 value is approx 1.618 and so on. So for that, I will make you sure that you have read this, and for that I'll show you the lecture first notes, and this is the note where you have defined this. Now from here I can write A is equals to B into 5. So now with the help of this, we can write A plus B upon A is equals to 5 as well. So A plus B, we know this is 360 degree divided by A is equals to 5. Now clearly from here, 360 degree and either A or B, you can take any of this, okay? Can you take the LCM of these? No, the LCM not exist, because see, A and B both are irrational, and the LCM of irrational number never exists. And therefore if you draw an angle B or A and continuously draw again and again, you never gonna repeat any time. But why we not take any other irrational number? But before this, let's see why irrational number are useful. Because when you repeat B and B again and again, you will get next time here, you will get next time here, means they never overlap each other, and therefore they get the maximum sun exposure. But why not other irrational number can come? Because with 360 degree, other irrational number also has no LCM. So the answer is the 5, which is the golden ratio, is most irrational. But what is the benefit of this here? So as you know, the pi, which is an irrational number, and it is less irrational than the golden ratio, and therefore in the second and third solving, it rushes towards its pi approximation fastly. So a fraction can be a comparable thing with the pi approximation. As in this video lecture, I have told you that phi, the golden ratio, has more irrational, therefore it is very difficult to get the approximation of the phi by simply writing the fraction. But pi can be achieved by simply writing a bigger fraction. But phi, the golden ratio, cannot be achieved directly. No fraction can mimic this. Therefore the LCM can't exist with this. But in the case of pi, the larger fraction can mimic the pi approximation, okay, and can mimic the pi approximation very greatly. And therefore with comparison to the golden ratio, the pi greater fraction can mimic the pi approximation very greatly, and hence LCM of it can exist. And as LCM exists, there is an overlapping in the leaf, which creates a hurdle in the perfect sun exposure in big and large plants and trees. And therefore the nature doesn't prefer to use other irrational number except the golden ratio. And this is the real beauty of golden ratio. So don't rely on the baseless claims. Understand its real beauty and the concept behind it, that why the nature wants it. Not everywhere, but why somewhere. But again, there is no perfectly always golden angle exist. But according to the result, the nature must try to prefer this, must try to approach this angle for maximizing its sun exposure. Hopefully you get it, so don't forget to like and subscribe.